Now next, we're going to see some of this put into action to understand what's coming in artificial intelligence. I've asked Mansour Raad, one of my colleagues of many years, to come up and kind of enlighten us on what is the path forward with artificial intelligence. Mansour?
Thank you, Damien. Ladies and gentlemen, we are in an AI-first world today. Many organizations and institutions have already implemented artificial intelligence, and others are exploring it to find out how they can leverage their data, in this case, big data, to gain more insight, in our case, geo-insight. Now, it is daunting to look at the list of words and context here, and we should not worry too much, because I'm going to focus here on three main areas in here. Artificial intelligence deals with how machines can take a task and make it look like natural intelligence. To achieve artificial intelligence, we can apply machine learning. Machine learning deals with algorithms in a computer, in a machine, to discover information and reveal hidden patterns. And one of the implementations that has been taken over the world right now in machine learning is called deep learning, because its structure mimics how the brain works and how the brain is adaptive to solve the problem. Now, people do not know this, but we already have implemented machine learning implementation in the ArcGIS platform as geoprocessing tasks to perform classification, to perform prediction, to perform clustering. We have used support vector machine to take land cover and to do segmentation. We used density-based clustering to help us automatically discover clusters. And using geographically weighted regression, we let geography find out and mutate the model to help us with predictions. Now, in addition to using the internal tools, we can also connect to external tools, such as TensorFlow and scikit-learn. And using, for example, the ArcGIS API for Python, we can connect to now platforms like Azure and IBM Watson to invoke their APIs and to perform these offsite and bring the analysis in to do further analytics in here. Now, in machine learning, there are several modes of learning, and I want to focus on two of them. One of them is called supervised learning. What does it mean? That means you pass the machine data and labels, and the machine discovered the relationship between the given data and the given labels. There is another mode called unsupervised learning. And in unsupervised learning, you just pass in the data. And without explicit programming, it discovers the labels and pops it out. This is an amazing mode, and we're going to be using it to solve the following problem. An oil and gas operator wants to perform inspections on their remote oil wells and wants to generate an optimized set of routes to perform those inspections. However, the street network to generate these routes is incomplete, and street segments are missing. Now, a solution is to go ahead and to manually digitize all these street segments, the missing ones. But as you can imagine, this will be a very daunting and time-consuming task. And of course, the data will be automatically out of date. Another solution is to use GPS breadcrumbs from previous visits and infer patterns from that. Now, if we put a few of these GPS breadcrumbs, we do not see anything. However, if we take multiple days and multiple trucks and we put the GPS breadcrumbs, suddenly something appears in here. And if we do assemble them, the tracks, we will get something like this. Now, I know what you're thinking. This is a little bit exaggerated, but this could happen. And we have a solution for this. We used an ensemble of unsupervised learners to solve this problem. First, we find the breadcrumbs that are not on the streets. Second, using density-based clustering, we can group these breadcrumbs by proximity to firm clusters. Third, and this is my favorite part, we use a self-organizing algorithm to map lines to points. And let me repeat this. We're going to be using something to map lines to points. Let me show you this in action. Watch as the machine is learning how it's going to take the lines and mutate them to get to the lines. Did you see that? Let me repeat this again. Watch it learn. Isn't that cool? Isn't that fantastic? And once it figures this whole thing out, now we have custom roads that we can now snap to the existing roads, and voila, we have a fully connected traversable network. So what we've done, we've used unsupervised learning, self-organizing algorithm to take GPS breadcrumbs and turn them into navigatable street segment. This is pretty cool, right? I think this is fantastic. And this is just a few of the many machine learning algorithms that you too can use with the ArcGIS platform. Thank you.
Mansour, did we save the best for last?
I know. Well, this is a very daunting task that people have been doing for they wanted to do for a long time, and I think now we have a solution for them to help them out. And rather than spending their time digitizing, right, we let the machine figure it out for them.
Where were you 10 years ago?
I'm sorry. It took a little bit of time.
I had to digitize.
Right?
I needed you a long time ago.
Big data, IoT, machine learning. Finally, everything came together now, and this is what's making this possible.
Yeah, I mean, and what you said, we have these capabilities today.
Yes.
Right? We can do it now.
Yeah, so this is the exciting part.
Excellent. Thank you, Mansour.
Take care.
All right. Let me do a quick wrap up. All right, so to wrap up some of the things we've seen this morning, we were talking about that digital twin. We saw examples with creating content, being able to take that information and collaborate and share across the organization. We saw some examples of monitoring information, and when you're monitoring, being able to make timely decisions. And finally, the big data and understanding, recognizing patterns and trends, or even creating road networks.